Where to from here? Well, we're trying to get to not A or B and C on both of these possibilities, demonstrating that no matter which of the two things is true that makes a conditional true, we get the formula we're trying to get to, which is it is not the case that A on the one hand or B and C on the other. So, this is going to reinforce something that I've already, I don't know, strange dialectical thing that I've already gone through, which is a weird move in and of itself. That weird move being that, and it's only weird if you go only by the everyday sense of or. It's not weird once you recognize that the or in the system is just at least one. And that is, you can go from thing to thing or whatever. And so that's what we're going to do here. Since I have not A, I thus have not A or whatever I like. And what do I like? I definitely like B and C because that's what I'm trying to get to. So, not A or B and C. Don't know why I decided to abandon, the lines that the notebook page gave me, but sometimes my decisions are questionable. So, I'm just going to do this right here, which is indicating like, okay, yes, one branch is to the left of this unofficial dotted line, one branch is to the right, just so nothing gets screwed up. Just so the reader, i.e. me, who's going to be grading your work, could, understand what you're doing. So, same move in principle over here. If I have B and C, then I have or B and C. And it is important to get the order right. Logic is nothing if not anal retentive, so it wants, if we want to generate a string of symbols that is the exact string of symbols. You as a human being who understand meanings, understand that it doesn't really matter which order you present the disjunction in. But if you imagine that you are writing for a totally formal system that is just operating on the shapes of symbols, those two symbols, so not A or B doesn't have the same shape as B or not A. And so it might be like, I don't know. But so you want to iron out as many of those possible infelicities as possible, just by keeping everything exactly in the order that you want to get to. And so yes, because it doesn't matter to you, your human mind, which of the two ors comes first, you have though you have a tendency to add an or to the right, add a disjunct to the right across an or from whatever you have, you should resist that tendency and instead try to generate the exact string of symbols that you want. In this case, it's exactly what is to the left there. So that's whatever or the value B and C. Checks out. No matter which way you go with this conditional, you can get to it is not the case that A or the value B and C. Another entailment proof, outlining one weird feature of the conditional.